Hi guys, welcome back to my channel. In today's video, I'm going to be explaining how to do another math problem from the calculator section, and I'll link down the practice test this problem is from down below so you guys can see the problem and get a feel for it yourself. So I'm going to be doing number 27 today. So let me read the problem first. In the xy plane, the graph of 2x squared minus 6x plus 2y squared plus 2y equals 45 is a circle. What is the radius of the circle? So I boxed circle and radius because we're given the equation of a circle, which is super important, and we're trying to find the radius. So when you're stuck, always write down what you have already. So that's what I did here. I wrote down the standard form of a circle, which we're all familiar with. But what may not seem so familiar is the formula or the equation we're given in the problem. And not gonna lie, the first time I saw this, I was also daunted and I was like, how do you do this? But there is an algebraic technique called completing the square that can help you change this equation into this form, which is super helpful because all we would have to do is take the square root of the term on the right side of the equation. So for this technique, completing the square, you'll always need to make sure the the number or the coefficient of the x squared and y squared terms are both 1. So in order to do that, we'd have to divide by 2. So if you divide everything by 2, you're going to get x squared. Remember, don't just divide the left side by 2. You have to, whatever you divide by one side, you divide the other side by 2. So whoops. So I also left some spaces here because it'll help us do the completing the square method. So I just divided everything by 2, and I just did the mistake I told you not to make. Divide the right side by 2 as well. 45 divided by 2 is 22.5. So I wrote that right there. So the first thing in completing the square is knowing b over 2 squared. And basically we have two sections here. So we have this section and this section that we're going to use a b over 2 squared. So our first thing we have to do is locate where b is. So in our first part, b is -3. So -3 divided by 2 is -1.5, and then 1.5 squared, or -1.5 squared, I keep forgetting the negative, would be 2.25. So I'm just gonna write plus 2.25. Oof, I don't have a lot of space, but it's okay. And then you're gonna do the same thing to the other one. 1 is b in this case, so 1 divided by 2 is 0.5. 0.5 squared is 0.25. So I'm just gonna rewrite that down below so then it's more clear, because obviously it's really not clear there. Sorry for the shaky camera. Okay, and you should know this rule from Algebra 1 that you're not supposed to just add something on one side and then not do that to the other side. So we're obviously going to add 2.25 and 0.25 to the other side. So after we do that, we would get x squared minus 3x plus 2. Plus 3, I don't know. Y squared plus y plus 0.25 equals... Great, I didn't leave enough space again. Okay, I'll just erase that after. But what would that be? 24.75. So that would be 25 on this side. And we don't even need to do anything else. In this case, our answer is A, because as I said from the beginning, this 25 corresponds to this r squared. So since 25 equals r squared, and we're finding r, we would just take the square root of both sides, and then we'd find r equals 5. But just for the goal of today's video, I'm just going to complete the final thing to show you the whole purpose of doing this in the first place. So the reason we're even completing the square and using this is so that we have two polynomials that could be changed into a perfect square polynomial. So that's what we did here. We have two perfect square polynomials right here. And yeah, that would be our final equation to change it into this form right here from the beginning. So yeah, that was it. Thank you for watching this video, and thank you for all the love in the comment sections. I really appreciate the few people that commented. I really appreciate that. Love you guys, and I'll see you guys next time. Bye!